we will simulate coronavirus patients breathing in an airplane using ANSYS Fluent software. The present model is designed in 3D dimension using Design Modeler software. The meshing of the model has been done using ANSYS meshing software, and the mesh type is unstructured.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by Mr. CFD. Or if you are watching the training video, click on the Mr. CFD logo and subscribe.
Under the General Setup tab, you can see different buttons from scales to units. By clicking on the scale, now in order to define the type of injections and particles, you just have to click on injections. In the Appear window, you either can define new type of injections by clicking on Create button, or you can change the settings for this defined injection just by clicking on the injection's name and then clicking on Set button. Also, by clicking on Thermal tab, the temperature of the airflow entering into this boundary will be shown to you. And as for the DPM tab, by clicking on this tab, you can see that the discrete phase boundary condition type is defined to be escape, which means that particle will only get away or escape from this boundary. After double-clicking on the method, you will see that a new window will appear showing you the pressure-velocity coupling. Also, you can see that the spatial discretization methods are shown in this window. Also, you can change this discretization into other formats, like you can change them into first order event and the other options available for each variable under their combo list. And for the simple pressure velocity coupling, the simple algorithm is kind of an iterative solver which uses a relationship between velocity and pressure corrections to enforce mass conservation and to obtain the pressure field. After double-clicking on the Run calculation, a new window will appear. In the Appear window, under the Parameters section, you are able to set the number of iterations you want your simulation to progress. After defining the number, by clicking on Calculate, the software will start the simulation process. Now, in this 2D velocity contour, you can easily see the velocity magnitude of the airflow inside our computational domain. For example, you can easily see the velocity magnitude of the airflow near the mouths of the people inside the airplane, which is an increased amount in comparison with other sections. Also, in order to see the 2D contours of other variables, you just have to select different variable from the contours of section. Now, in order to see the particle tracks, just have to right click on Particle Tracks button and then select New. After that, a new window will appear. In the Appear window, all you have to do is to select your desired injection, which in this project we had only one injection. By clicking on that injection and clicking on Save or Display button, the software will give you the particle tracks. Now in this contour, you can easily see how the particles have moved after they had exited from the people's mouths. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
Coronavirus is currently recognized as the greatest human challenge in the world. Because of this disease, in addition to being dangerous to human health, has a high transmission power between a sick person and healthy people. Breathing of a patient person without mask into an enclosed space can transmit the disease to nearby people. One of the important recommendations of doctors regarding the prevention of disease transmission between people is to maintain social distance in different places, including public transportation. For example, the short distance between the passenger seats of an airplane can increase the likelihood of transmitting coronavirus from a carrier to other nearby people. In this project, based on the CFD method and using ANSYS Fluent software, an attempt has been made to simulate the respiration of viral air from the mouths of several patients carrying coronavirus in the airplane. This model includes a computational domain in the form of an airplane and sits inside it, on each of which a passenger is modeled. The present model is designed in 3D dimension using Design Modeler software. The geometry of the model includes the interior of an airplane. Inside the aircraft, several rows of seats with passengers sitting on it are designed. This designed airplane has several sections for the entry of fresh airflow, which includes an entrance section on the roof of the aircraft and two entrance sections on the upper two sides of the aircraft, and several sections installed under the seats of each passenger, and also two exit sections on the lower two sides of the airplane. The meshing of the model has been done using ANSYS meshing software, and the mesh type is unstructured. The element number is equal to 1,316,384.
To benefit from Master CFD services including simulation, consultation, and training, contact our experts via info@signmastercfd.com.